My name is Vincent Saint. I'm a project engineer here at Risk Management Professionals, and thank you for joining us this morning. Today, I will be providing guidance on this. Stop using the mouse. 1 second, sorry. Today, I will be providing guidance on dispersion modeling software for hazard assessments with an emphasis on mostly hydrogen fluoride, and we're going to arc a little bit on ammonia. But this should be a fairly short webinar, but I'll try to make sure that I convey as much information as I can within that time. These are some of the services that RMP offers. As you can see, we can provide key services like process, safety, and risk management for both OSHA, EPA, and CalARP. We also provide PHAs, HAZOPs, and what-if studies. And we've had an extensive experience, about 2 decades of risk-based applications. Our location, our headquarters is in Irvine, California. We also have satellite offices out in Houston, Norfolk, Walnut Creek, and our contact information is right there on the bottom of the screen. All right, so this is a summary of what I'm going to be presenting today. First, we have our introduction. Then I'll provide a little bit of overview on hazard assessments. Then we're going to dive into the types of software available. And then I'll have examples or applications of each of the software. And lastly, we're going to compare the results of each of the software and talk a little bit about why you would use one over the other. For introduction, these are the regulations that outline the requirements of the hazard assessment. So as you can see, we have CalARP and the EPA RMP. OSHA does not require a hazard assessment, so if you are not covered under CalARP or RMP, then you don't have to conduct a hazard assessment. And these are the actual regulations, so you can look them up and actually read what the regulations require. So what is a hazard assessment? Hazard assessment is basically an off-site consequence analysis where a worst case and alternative release scenario is studied to determine the potential impacts of a chemical release. So you want to see how far that distance would reach and what kind of population sensitive public and environmental receptors that would be affected by that potential release. And also it is required that an EPA approved software, modeling software is used. So that's pretty much the basis of our webinar today. And also you need the population data, like I said. 5-year accident history is also required, and this has to be updated every 5 years. So if you need more in-depth information regarding hazard assessment requirements, we have a webinar that solely talks about hazard assessments in our website. If you need a link, feel free to contact us and we'll be more than happy to give you that link. All right, so here are the 3 software that we use here at RMP. So this webinar, I'm going to base it solely on these 3. I know there are tons of other softwares out there that you can use for modeling purposes, but we're going to stick to these 3 for purposes of this presentation. So we have EPA's RMP Comp, ALOHA, and SLAB view. So I'll give a little bit background about each one. RMP Comp utilizes values from reference tables that were put forth by the EPA to estimate the endpoint distance of a release. These tables can be found in the EPA Risk Management Program guidance for offsite consequence analysis. So RMP Comp is basically a more convenient way of using these tables. So instead of having to look up one of these tables and figuring out the distance of your release, you just plug in the numbers online and you get your results. And also RMP Comp is the most user-friendly of the 3, only requiring the most basic values for input, which are usually the quantity of the chemical and the temperature. But this could vary depending on the chemical or the scenario used. They might ask for a little bit more values. But like for the alternative release scenario, you have to input the release rate, which also can be calculated in RMP Comp. ALOHA is a little bit more detailed in terms of the parameters it requires to calculate the endpoint distance. And also SLAB view as well is a little bit more as opposed to ALOHA. So I will show what these parameters are in the next slide. But the most significant difference between ALOHA and SLAB view is the algorithm that they use behind it to calculate the endpoint distance of a release. So the next slide, I'll present a scenario and I will model it using the three softwares that we just talked about. So here's a scenario. We have a hydrogen fluoride worst case release. There's 10,000 pounds of it. We're going to use 77 degrees Fahrenheit, 50% relative humidity, and F atmospheric stability class. And also I should add on there that we're going to use 1.5 meters per second wind speed. It is important to note that I made the temperature, humidity, and stability class the same in all three of the software that we're going to use, since I want to compare the software results using the same parameters. So I want to show the values as constant and the software as the variable so that we can compare each of the results in terms of the software that we're using. So the next slides I will show you the step-by-step procedures of using each of the software, starting with RMP Comp. So once you open up RMP Comp, it will immediately show you a screen with all the chemicals that are regulated. This is where you choose the chemical that you want to model. In our case, it's hydrogen fluoride anhydrous. It should be right in the middle of that screen there. And then next, once you press submit or OK, and then it goes to the next page, which you need to input the scenario type, the physical state, quantity released, and the terrain. So for our scenario, it's a worst case, so we choose the worst case scenario. The quantity released, as I said earlier, is 10,000 pounds, and the terrain type is urban. So basically, urban means that there's buildings and a lot of surrounding obstructions in the area. Typically, we use rural when you're out there and there's really nothing in the immediate area, and that's when you could potentially use rural. But for the most part, urban is usually what's the default value. Then we press submit, and you get your result. Endpoint distance of 4.2 miles. So like I said, it's pretty easy and straightforward to use. And next I will show you ALOHA. This will be a little bit more involved and will ask for a lot more information, but before it will actually calculate your endpoint. So once you open up ALOHA, the first thing it's going to ask for is the site location. I didn't show it here since that step is pretty self-explanatory. I believe you just look for, there's a list of cities in ALOHA, and if yours isn't in there, you can create a new one, and it just asks you some basic information like elevation, and I'm not sure if it asks for latitude or longitude, I can't remember, but those are pretty easy to find online. And so the next step after you put your location is the chemical data. So this is a screen that you will see. Once again, choose hydrogen fluoride, and we press select. And once we press select, the next set of parameters that we need to populate is the atmospheric data. This is where you input the wind speed, the direction, the measurement height, the ground roughness, and the cloud cover. So for our wind speed, like I said, it's 1.5 meters per second. The direction, it doesn't really matter, since when we get our results, we're going to have a radius. So it doesn't matter which direction the wind is blowing, we're going to account for all that. And then you have your measurement height above the ground that basically just says, like, typically where these measurement devices are, that's how high off the ground they are. And usually 3 meters is the default value. And then your ground roughness is the same as the surrounding terrain. It's urban or forest. And then we choose partly cloudy to be conservative, but if your facility is located in an area where you get more cloud cover, or it's a little bit more clear, like if you're in Southern California, then you can definitely use the other options. Just make sure you document it. You have proof that it is sunny for the most part of the year. And next we have our air temperature. So similar to RMP Comp, we're using the default values of 77 degrees Fahrenheit, an F stability class, and 50% humidity. Once again, these values can be changed depending on the location of your facility. Just make sure that you have documentation to back up the values that you use. So once we press OK, then we're going to go to our source type. So after you input all the atmospheric data, there are a number of different sources available, and you just need to determine which is more appropriate for the release scenario that you're modeling. In our case, for a worst case scenario, a direct source with a release duration of 10 minutes was chosen, because regulation states that a worst case scenario is a release of all content in a vessel in a 10-minute period. So we plug in our quantity, which is 1,000 pounds per minute, multiplied by 10, which is our total release of 10,000 pounds of hydrogen fluoride. So once Once we get that all plugged in, we press OK, and then we get our results. It shows an endpoint of 4.4 miles. Next, I'll go through SLAB view modeling walkthrough. From what I said, the main difference between the ALOHA and SLAB view model is the algorithm that is being used. SLAB view uses the SLAB algorithm, which is primarily useful for denser than air substances. So SLAB view would provide a more accurate result as opposed to ALOHA in most cases involving denser than air releases. Similar to ALOHA, the location information will be filled in. This is not shown, like I said earlier, it's pretty self-explanatory. But next, we have the screen showing in this slide where we choose the release option. For worst case release, we chose a horizontal jet release since the release time can be specified to the regulation requirement of 10 minutes. The other releases may be applicable to your facility, but we chose this source since it has the parameters that we need to satisfy the regulations. And next, we input the chemical information. All of these values are already populated for you by the software, and they have a whole list of chemicals. But they can be modified as needed since these are default values. So as you can see here, we chose our chemical, which is hydrogen fluoride. You see the vapor heat capacity. Those can change depending on, so each of these values can change depending on temperature, pressure, and all the values that you can change. So basically, if you feel it's more appropriate that you change some of these values, just make sure you have the documentation approved that you can use it, and you can go ahead and modify it. Next, we go to the spill parameters. So here's where you input your source rate or the release quantity, the release duration, and the temperature of the material in the storage. For this scenario, I chose the material temperature the same as the ambient temperature for consistency. And also one of the differences here from ALOHA is you can specify the area of the source, so how big the rupture is in your vessel or tank. And it's important for certain chemicals with different properties. So they could vaporize more when the pressure is higher. So that depends on how big how much flow is coming out of the vessel and into the environment. Next, we have the MET parameters, or your atmospheric data. So again, we stick with our default values for consistency. We have our surface roughness of 1, which corresponds to an urban terrain. So the tip box right next to it shows the appropriate number for the surface roughness that you would want to use. Next, we have our wind speed, which is 1.5 meters per second. Temperature, again, is 77 degrees Fahrenheit. Relative humidity, 50%, and the stability class of F. So once we input all that data and we press OK, we get our results. In the bottom of the page there shows the endpoint distance in meters. So you can just convert that to miles, and that is your endpoint distance. I realized that I didn't go through the toxic endpoint concentration of hydrogen fluoride, which is 20 ppm, parts per million. So that's the concentration to where the endpoint would be at that. That's the concentration that you would need before it's less harmful or harmful. So at 20 ppm, the toxic endpoint distance is 4,363 meters, which roughly converts to 2.7 miles. All right, here's the comparison of the data from each of the software. As you can see, the differences between the three. I mean, RMP Comp and ALOHA are pretty similar. SLAB view is significantly different, and I went ahead and did ammonia as well. I didn't have to show the steps. It's basically the same step. It's just in the beginning, you choose chemical instead of choosing hydrogen fluoride. You go with ammonia, and pretty much the rest is the same. So RMP Comp. So the reason of the differences in endpoints is that RMP Comp uses these reference tables, like I said earlier, that were calculated by the EPA. These values are set using the default temperature and, well, default atmospheric data that I spoke of earlier. And basically RMP Comp just grabs your input and matches it with the one box, the one result in those tables that has the closest to the values that you inputted. ALOHA basically uses the same calculation, except some of the values are not set, like the temperature, wind speed, stability, cloud cover. ALOHA calculates the distance according to what you input. So it's a more of a, I guess, more of a real-time calculation instead of a set data. So the reason why ALOHA is a little bit higher, probably because of how the tables are set up. So it's sort of a range. So from, I'm not exactly sure what the range are, so I'm just speculating here that I'm guessing maybe from 8,000 pounds to 10,000 pounds of hydrogen fluoride. It could be 4.2 miles. So I'm saying that the 10,000 pounds could be on the extreme limit of that particular distance to where it's spilling over to the other side, but it's not quite there yet. And this is where ALOHA shows that it's 4.4 miles because it's calculating it a little bit more accurately. And SLAB is a little bit smaller because SLAB accounts for more information, the source area, the properties of the chemical being released, and therefore it has a lesser endpoint. It also has other values that you could change to where it drastically changes your your endpoint distance, but that depends on the values that you use and if you have the documentation to back it up. And the same with ammonia. RMP Comp had 1.5 miles, ALOHA is 2 miles, and SLAB is 1.1 mile. All right, so a lot of times it can minimize endpoint distances depending on the software that you use. Sometimes using a more accurate software can benefit the facility in terms of public perception or corporate perception. So basically, for some companies, it could be important for the public to know that the chemical that's in their neighborhood won't go as far as it could, or for corporate purposes, you might want it to reach out a little bit higher. So using RMP Comp as a more conservative measure would be more, I guess, would be more beneficial since it would show a greater release or a greater area, and it would give you, I guess, better planning on contingencies just in case it does go a little bit further than what SLAB would give you. And also, if you don't want to use RMP Comp, since it is fairly generic, you can use you can use other software so that you can tailor the modeling to be more specific to the facility, pertaining to its location, the atmospheric conditions in the area, and other relevant information that could determine the modeling results. And just remember, if you do change or modify any of these values, remember to document and back up how the calculations were done and what assumptions were made. And that's pretty much the end of it. So here's the upcoming webinars and events that we have. On October 4th to 7th, we have a Reader National in Vegas. So come join us if you're going to be in the area. October 11th, we have another webinar regarding security vulnerability assessments. And October 20, we have a webinar, IIAR standards and how they apply to RAGAGAP. Any questions?
All right, so our first question is how do you modify default HF parameters for facilities using modified hydrofluoric acid?
I guess in what way? Is it the concentration or the actual? Is it the concentration of HF that you're trying to modify, or is it the actual, I guess like heat capacities, density, stuff like that? Because if I'll answer both, I guess, since you won't be able to. Concentration-wise, RMP Comp does have a solution to where you can choose a solution of hydrogen fluoride, but in other cases, in ALOHA, ALOHA you can't use it, but in SLAB you can modify the parameters within the chemical itself. So I hope that answers your question.
All right, so we have another question here. Is there guidance for what values to use in ALOHA used for RMP?
The values, I guess, I'm guessing you're talking about atmospheric values. Yes, the requirements are in the regulations, and also to be safe, you could use RMP comp to where all the values are already in default, and you can carry that over to ALOHA. If not, you can always use always use atmospheric values that are more, I guess, relevant to the facility location. But you just have to, I believe, for temperature, you have to look for the highest recorded temperature in the last 3 years, and pretty much average it out. Just make sure you have documentation to back up the values that you're using, and you should be okay. Any other questions? Okay, thank you.